let's continue on integrating with these trig functions and LNs. So for part E, first thing I want to do is distribute. So that would be secant squared plus secant tangent. Well, now I can integrate each of the two terms. There's nothing special about it. So tangent of t plus secant of t plus c. Okay, part F, that's kind of like part A and B from the previous, on the previous page of your notes. So go ahead and look at that on your own. So let's go to example G, because now it's a definite integral. So again, you have a fraction, so look and see, is the derivative of the denominator, is that on top? Yeah, it is. So ln absolute value x plus 2, and we're integrating from -1 to 1. So plug the 1 in, plug in the -1, and ln of 1, that's just 0. So ln of 3. Okay, over here, example H. Well, we've integrated this function before. Remember, we just moved the 1 over x to the top. So the derivative of the denominator is the numerator. So ln absolute value ln of x going from e to e squared. So we're going to plug in e squared. So ln of e squared, that's just 2. So I have ln of 2 minus ln. Now I plug in the 1. Well, ln of 1 is, or I'm sorry, ln of e is 1. And ln of 1, that is 0 again. So we end up with ln of 2. Okay, example 4. Find the area of the given region bounded by the graphs of those equations. So if you want the area under a curve, what do you have to set up? You have to set up a definite integral. So we're going to integrate from x equals 2 to 4 of 2 over x ln x dx. Well, you've kind of seen this one before too. We just sort of did it up there. You just have a 2 instead of a 1. So pull the 2 out. So the integral of 1 over x ln x, we just did it. It's going to be ln of the absolute value of ln of x. Went from 2 to 4. So plug in the 4. And plug in the 2. And this can actually kind of simplify. So the 2's, they're common. We can pull those out. And when you subtract with logarithms, that means you can also divide what's inside the logs. So it'd be ln of 4 over ln of 2. And now I can keep going, because the ln of 4, that's like ln of 2 squared, so I can pull its exponent down. So I have 2 ln of 2 over ln of 2. So the ln of 2's cancel, and I have 2 ln of 2. And if I really wanted, I could pull that 2 into an exponent and say that's ln of 4. So just be aware that these log properties can kind of come back to get you. All right, so let's stop the video here, and then we'll do the next examples. in the last video of the section.